Hello and welcome to our Capstone design project for Group 17. I'm Serrano and these are my group members, Ivani and Kate. We built a train ticket scanner. Let's walk through the problem which we tried to solve with our Capstone project. A common procedure we follow when we get on trains, let's say, for example, on NJ Transit, first of all, we had to buy our tickets, either digitally or from the ticket ticket stations at the train stations. So it's either a paper ticket or a digital ticket. So and then we get on a train, we just hand the tickets to our conductors, and that's it. But looking at it from a conductor point of view, the job is quite daunting and tedious because the conductor has to pace up and down multiple times to make sure each of the 3,000 or so passengers have paid for the tickets and have and get on and off at their correct destinations and sources. So we came up with a solution to address this problem and kind of ease the job of the conductor a bit. So what we tried to build was a train ticket scanner that is going to be attached to the front of each passenger, and that's going to scan the ticket of the passenger. So our device is going to be based on Raspberry Pi, and it's going to have a camera which the passenger will show his or her ticket to, and the device will scan the ticket, translate it into a string, and then send it to a database, the train ticket server basically, and then reply back with a valid or invalid ticket request. So if the ticket is valid, the passenger is good to go, and it will prompt a message on the screen saying the ticket was successfully scanned and is valid, and that way the conductor can pass by and see the screen of the device and see that the passenger has paid for the ticket already, and he doesn't have to ask or bug the passenger for the ticket and disturb him. So if the ticket is not valid, then the passenger will be asked to scan the ticket again and go through the same procedure all over again. So what the design requirements for the device was to show the time, the current location of the train, estimated time of arrival, seat transfers, and connecting train timings to status in case the passenger wants to transfer to another train to get to a different destination. And for seat transfers, if the passenger wants to sit with someone he recognizes in his own car. And so these are kind of GUI implementations, except for the seat transfers, which is a high level implementation we didn't really get into. For our adopted approach, what we did was, what we planned to do was first scan the ticket, then check with the database, and then come back with a query saying if it's a valid ticket or not, and then kept on adding higher and higher level implementations, for example ETA, location of the train using a GPS, and seat transfers, which would require ultrasonic or proximity sensors. So coming to the hardware design, what we did was let me check if I'm recording. Okay, I am. For our hardware design, what we used was the bare bones hardware design was just a Raspberry Pi 4 with a Pi camera. We initially started off with an Arduino, but then realized the Arduino was not powerful enough for processing images because we're using OpenCV, which is an open source computer vision software, Python package rather. And so we decided to go with the Raspberry Pi, and for our final product, our device is supposed to have a Raspberry Pi, a Pi camera, a Pi display, a GPS sensor, which we didn't really get our hands on because pandemic delivery issues, and a proximity of ultrasonic sensor. So we decided not to go with the proximity and ultrasonic sensor because we're using OpenCV, which uses computer vision, and for using OpenCV, we can also detect if there's a passenger on the seat or not by just using the Python package, using Python scripts, and we can do away with proximity sensor, do away with OpenCV instead of proximity sensor. Then let's look at the software implementation that we did. So what we did was create a GUI with 3 pages. Start page, which will have a button. When pressed, it will execute a Python script, which will start the video stream of the Pi camera and send each frame of that video to OpenCV. That takes and detects the QR code / barcodes, depending on what kind of ticket it is, and then decodes it into a string, and UTF-8 string, and then that Python script sends that string into another Python script that will connect to the MySQL database running remotely, which we didn't really implement because I've been having trouble with that. And that Python script will check with the entire list of tickets in the DB or the database and see if the ticket exists or is unused. If both are true, then that's a valid ticket and the passenger is good to go. Otherwise, if it's an invalid ticket, that is, if the ticket doesn't exist in the database or is used already, it will prompt the user to go through the whole process again through the retry page, and for success, it will just show the ticket was scanned successfully. So let's try and see what we got done until now. So this is a SSH connection into a Raspberry Pi. I'm gonna try and run the GUI, what we did. So yeah, this is our app for now. It's pretty simple, pretty bare bones, nothing too special. And here let's say we press on scan ticket, and here I should be having a train ticket. So this is the train ticket I have right now. And if I scan it, you can see here, hold on, let me pull that up right here. If you scan that, right, so it says scanning, right, and it decodes that QR code into the string. And we didn't really get farther than this. I've been implementing and stuff, but didn't really get farther into verifying with the database what if this ticket is valid or not. But this is a string that's going to be sent to the database and then get checked with all the entries in the database. And if it's a valid ticket, the GUI should be loading another page right here saying the ticket was successful, the ticket scan was successful and it's valid and you're good to go. Otherwise, it will prompt to scan the ticket again. So this is what we have so far. Hopefully we get more of the basic implementation done before the Capstone Expo, and I hope I'll see you in the Capstone Expo. Thank you.